Hello everyone, welcome back again to Excellent Solutions, a guide to score 300 plus in Jamb. Today we are going to be discussing physics and the topic is thermal expansivity. We are continuing from question 16 to 20 and we saw question 11 to 15 in my previous videos. So kindly click on the like, share and subscribe button to this channel as you view this video so that others will also benefit from it. Our question 16 today says, on a fairly cool rainy day, when the temperature is 20 degrees Celsius, so we now have our question 16, theta 1 equals to 20 degrees Celsius. Okay, the length of the steel rod track is 20 meters. L1 equals to 20 meters. What will be its length on a hot dry day when the temperature is 40 degrees Celsius? Theta 2 equals to 40 degrees Celsius, and we are asked to look for L2. So coefficient of linear expansion of steel is 11 exponential minus 6. So we now have alpha equals to 11 exponential minus 6 per Kelvin. So we are asked to look for L2. We call that our formula L2 equals to L1 open bracket 1 plus alpha delta theta. So we now have our L2 equals to L1 is 20 open bracket 1 plus our alpha is 11 exponential minus 11 exponential minus 2, then times this delta theta we have 40 minus 20. Theta 2 is 40, theta 1 is 20. So we can now say L2 equals to 20 open bracket. We now have 1 plus, this one is now 11 times 10 exponential minus 6 times 20. So we can now have L2 equals to 20 open bracket 1 plus, if we now multiply this is the same as 2 exponential minus 1, 2 exponential positive 1. So we can now say 11 times 2, we now have 22 times 10 raised power up minus 6 plus 1. So we can now have also L2 now equals to 20 open bracket. This one is now the same as 1 plus 22 times 10 raised power up minus 5. So this is now the same as saying 20 open bracket 1 plus this minus 5. If we take it backward, we now have 0.00022, which is taking this on 1, 2, 3, 4, 5. We now have this minus 5. So now our L2 could be 1 plus 0, we now have 20 open bracket 1.00022. So if we now multiply this 20 by 1, we are going to have it to be equal to 20 points. If we now multiply this 20 by these 2 zeros, 3 zeros, we now have 0.00. This 0 will cancel 1 0 here. 2 times 2 we have 4, and which is the same as 20.004 meters. So the new length is 20.004 meters. And if you look at our option, we have it in option C, 20.004 meters. The next question is question 17, and this question says a brass rod is 2 meters long at a certain temperature. So L1 equals to 2 meters. What is the length for a temperature rise of 100 degrees Celsius? So this one, a temperature rise is given. That means delta theta is equal to 100 Kelvin. If the linear expansivity of brass is 18 exponential minus 6, so alpha equals to 18 exponential minus 6 per Kelvin. We are looking for L2. So recall that we said L2 equals to L1 open bracket 1 plus alpha delta theta. So we now have L2 equals to our L1 is 2 open bracket, this one is A, plus our alpha is 18 exponential minus 6 times our delta theta is 100. So this is the same as 1.0 exponential 2. So we now come with now L2 equals to, we now have 2 open bracket 1 plus 18 times 1, we have 18 times 10 raised to the power of minus 6 plus 2. So we now have L2 equals to 2 open bracket 1 plus, this is now going to be 18 exponential minus 4. When we add, we now have 18 exponential minus 4. So, and this is the same as, if we take back our point 1, 2, 3, 4, this is the same as 0.0018. That's 1, 2, 3, 4. So, getting it this way, we now have, when we add this one, 1 plus 0, we now have L2 equals to 2 open bracket. We add this one, we have 1.0018. So multiplying these 2 by 1, we now have equals to 2. 2 times 0, 0, we have 0, 0. 2 times 18, we have 36. So this one is now 2.0036 meters. If we look at our option, we have it in option A, 2.0036 meters. The answer is A. The next question is question 18, and this question says, a metal rod of length 20 meters each are laid end to end to form a bridge at 25 degrees Celsius. So we now have our L1 equals to 20 meters, theta 1 equals to 25 degrees Celsius. What gap will be provided between consecutive rails for the bridge to withstand a temperature, to withstand 75 degrees Celsius? Theta 2 equals to 75 degrees Celsius. And linear expansivity of the material is 2.0 exponential minus 5 per Kelvin. So alpha equals to 2.0 exponential minus 5 per Kelvin. So the question asks us to look for the expansion, which is the gap. So in this case, we can now say our L2 is unknown. So using L2 equals to L1 open bracket 1 plus alpha delta theta. We now have L2 equals to our L1 is 20, then open bracket 1 plus our alpha. We now have 2.0 exponential minus 5, then times our delta theta. We have 75 minus 25. So in this case, we now have L2 equals to 20 open bracket 1 plus 0.000002. That's minus 1, 2, 3, 4, 5. Okay. So we have 2 here. Then multiply by 75 minus 25, we have 50. So in this case, we now have L2 equals to 20 open bracket 1 plus, multiplying this, we now have 100. So this 100, we take these 2 zeros, we have 0.00100, something like this. So if we now come, we add this one, we have L2 equals to 20 open bracket 1 plus 0, we have 1.001. And multiplying 20 by 1, we now have 20 points. This one will reduce, this 0 will cancel 1 0, so we have 0.2 meters. So recall that expansion, we said expansion E equals to L2 minus L1. So we now have E equals to our L2, 20.02 minus L1, which is 20. We now have expansion equals to 0.02 meters. And if we look at our options, in option D, we have 0.02 meters. The answer is option D. The next question is question 19, and this question says, a bridge is made of steel. A bridge made of steel is 600 centimeters long. So we now have L1 equals to 600 centimeters. What is the daily variation in its length if the nighttime and daytime temperatures are 10 degrees Celsius and 35 degrees Celsius respectively? So theta 1 equals to 10 degrees Celsius, theta 2 equals to 35 degrees Celsius. Linear expansivity of the steel is 0.00012. So alpha equals to 0.00012. Okay, 0.125 Celsius. So in this case, we are asked to look for the variation, which is the extension. So we call that extension E. Extension is equals to L1 alpha delta theta. So we now substitute our value. E equals to L1 600 times alpha, which is 0.00012, times our delta theta, we have 35 minus 10. So we now have expansion equals to 600 times 0.00012 times, here we have 25. We multiply 600 by this by 25, we are going to have 0.18. So expansion equals to 0.18 meters. If we look at our options, we have it in option C, 0.18 meters. The next question is question 20, and this question says two metals P and Q of length L1 and L2 are heated through the same temperature difference. So that means they have the same temperature difference. Delta theta of P is equal to theta of Q. If the ratio of the linear expansivity of P and Q is 2:3, so alpha of P over alpha of Q is equal to 2/3. So that means alpha P equals to 2, alpha Q equals to 3. And the ratio of their length is 3:4. So L of P over L of Q is equal to 3/4, which is the same as 2:3. This is 3:4. Okay. What is the ratio of the increase in length of P to that of Q? So we are looking for the ratio of increase in length of P to that of Q. So recall that increase in length is expansion. So E is equal to L2 minus L1. So if we are looking for it here, we also recall that expansion is equal to L1 alpha delta theta. So expansion of P is equal to LP alpha P theta E over expansion of Q. E of Q, we have it to be equals to, you now say over LQ alpha Q theta Q. So this will now give us LP is 3 times alpha P is 2 times the temperature change is the same. So it's the same as theta over, in this case, LQ, we have 4 times alpha Q, we have 3 times the temperature is the same. So temperature cancel temperature. 3 cancel 3. 2 here, 1, 2 here, 2. We now have it to be equals to 1/2, which is same as 1:2. If we look at our options, in option C we have 1:2. The answer is C.